Hello, everybody, and welcome to this ForgeRock webinar, Security on the Edge, a new way to think about securing the Internet of Things. My name is Chris Kowalik, and I'm a Product Marketing Director here at ForgeRock, and joining me today is Ashley Stevenson, Identity Technology Director in the Office of the CTO here at ForgeRock. Thanks for joining us today, Ashley.
Thanks, Chris. Glad to be here.
So before we get started, I just wanted to give you a couple of housekeeping bits here. We're going to be going for about 35, 40 minutes or so, and then we'll save some time at the end for questions. So please get those ready to go. You can type them into the chat window actually at any time. So if you want to do that throughout the presentation, you're more than welcome to do so, and then we can answer them at the very end. We'll answer them verbally over the webinar here. Also, there will be a replay available of this webinar after the fact. You'll get an email on that. So if you want to send it to your colleagues or have it listen again on the things that we said, you're more than welcome to do that. And the slides will also be available for you to take a look at as well. So as we go into this discussion, we're going to be talking about both existing and forthcoming technologies. You may have seen recently that we've introduced a new concept in the way IoT device security is handled, and that's really what we're going to be talking about for the most part in the webinar today. So just wanted to let you know that before we move into the main content here. So please give a read of this slide. And then for those of you that are new, or if this is your first webinar with us or just want a quick update, I just want to very quickly frame what ForgeRock is so that you have some understanding of where we're coming from. We were founded about 7 years ago in Norway. We're now based in San Francisco. We have 10 offices worldwide, including the San Francisco office that I mentioned. We have over 400 employees, over 700 customers, and we have an even revenue split across Americas and international. And that's kind of unique in the fact that a lot of companies our size are focusing their customer interactions in one geographic region, and we have had a good mix from the very beginning. So we're well equipped to be able to deal with a worldwide customer base where we have customers in 30 plus countries, and we currently protect 1.2 plus billion identities. So that really says a lot about the scalability of the platform and the applicability of the platform to all kinds of different use cases. And at its core, ForgeRock is really a company that's designed around securing identities. And today we're going to talk a little bit about how to apply that idea and expand it so that it's not just sort of the old-fashioned way of thinking about identity, but actually applying some of those same ideas to securing the newer use cases that are coming down the line. So ForgeRock has really always pushed the definition of identity to include emerging technologies that can be protected and personalized using identity principles. So while the market was focused on employee identity, which is actually a fairly simple use case, you're trying to provide single sign-on, trying to provide some federation, that sort of thing, for a relatively small group of people in the tens of thousands. So while the industry was focused on that, we actually expanded our focus to move beyond that to things like providing a consistent omni-channel experience on mobile devices, for example, or being able to deal with the huge numbers of identities that are required for doing customer identity and access management. This is something where our platform has really shined over the years with its beginnings as a telco-oriented solution. It was designed from the beginning to deal with extremely high scale. And as you'll see, as we go through the presentation today, that not only applies to the customer identity and access management use cases that we have traditionally talked about, but that actually really applies as well to some of these newer use cases. So that kind of leads me into this idea of relationships. So once you have a high scale solution that's dealing with customer identities, customers have all kinds of different devices that they use. And then there's all kinds of different services. So one of the things that the platform is really, really strong at is mapping these relationships between all of these different things that have identities. And again, we're going to try to expand the definition of identity to include more than just users. We're going to expand that definition of identity to include users, devices, things, and services. And that leads us directly into IoT and this new model really for doing security for IoT devices using identity principles. And IoT has a couple of different main use cases. You could kind of arbitrarily chop it up between industrial use cases and consumer use cases, but really, I think the thing that's most interesting to us right now is we're kind of at the precipice between what I would consider, it's kind of strange to say this now, but traditional IoT. So the idea of hue light bulbs and maybe a building control system with a door, to being able to actually take those devices and have them operate on the edge with less interaction to the home chip or to the mothership, and talking about pushing more of the intelligence of the solution out to the edge so that these devices can operate more autonomously. And that's where Ashley is going to go through some things today to talk about how to do that. So as I said, identity relationship management is really something that we focus on. Kind of in the old days, again, when we talk about employees or even customer identity and access management, a lot of times it was about usernames and passwords protecting applications, right? Simple web apps or other types of applications, and that's a fine solution, and the product does that very well. But it is, maybe it's the kind of thing where the capabilities of the product certainly work great in that scenario, but there's so much more there. Today, it's about mapping the changing relationships between all the different identities, and these identities can be all the sorts of things you see around this circle here, and many other things. We like to talk about the idea that once you assign an identity to something, then you can control access to it and you can control access from it. And mapping the relationships between all of these identities is one of the things that really sets us apart. In the real world, it's pretty easy to determine who should have access to what, and your identity really determines that. And if you take that and extend that, you really want to be able to use a digital identity to ensure that every connection that's made, whether it's from a person or a machine to another machine or to another service, is authentic. And identity is the key to being able to do that. So you do that by assigning identities to all of these different things. Just like in the personal world, a person's identity determines the level of trust in any interaction. But when every piece in the system has an identity and a relationship with the other pieces, you're able to determine what level of trust to assign to each of those interactions. And that's really the key thing. And that's what extends the use of our platform beyond the classic identity model that you may be used to from other vendors or from the past. It's really about using identity principles to map the complex relationships between all the things that you might be interacting with or that might be interacting with each other. It doesn't even have to be people involved. It can be completely machine to machine. And using the identities to determine the level of access that should be allowed between those things is the key to being able to do these sorts of new use cases. So with that, I'm going to turn it over to Ashley to talk about, oh, I'm sorry, one more slide. Just to kind of go over what the platform is made up of. It's made up of several different modules that provide the different capabilities. So you can pick and choose these modules as you need for your particular use case. And the reason we're showing this particular slide, because some of you have probably seen it, especially if you're an existing customer and you're familiar with the authentication modules and the identity workflow modules and all of those things. But there's two new modules that we're working on right now. You may have seen the press release about a month and a half ago about ForgeRock Edge Security. And that is comprised of two different sets of technologies, the ForgeRock Identity Edge Controller and ForgeRock Identity Message Broker. And these things work in tandem with the rest of the platform to provide or really to extend the identity solution to devices on the edge. And that's what Ashley is going to talk about in the next slides here. So Ashley?
Thanks, Chris. So let's start off by just talking about the term IoT and what it is and what it means. I think it means different things to different people in different industries. So many of us may think of it in terms of a connected home and a Nest thermostat and opening your garage doors with your smartphone. But certainly there's industrial applications, there's retail applications. You can see here transportation. Basically, it lines up across all of the different industries. Everyone is getting their devices, right down to circuit breakers in electrical boxes, connected. Right, and so it really is everywhere, and everyone across these industries is dealing with some of the same challenges when it comes to securing those devices and being able to trust those devices and understand how they connect to the world, as Chris was saying. So really the point here is that IoT is everywhere, it's in every industry, and although it has different applications and affects business processes in different ways, everybody has the same needs around being able to trust their devices and being able to control who can see what devices and what data can flow from devices to clouds, and so on and so forth. So what we want to talk to you about today is what we see as some of the specific issues with trust and security in these devices, and how our Edge Security offering that we just recently announced can help, what we think, providing a unique solution to help that out. So what are some of the troubles with today's IoT approach? Now, typically, as we've seen in many other areas, security often takes a back seat to functionality, or at least it plays catch up at the end, and we've seen that some in IoT today, and definitely I think in the past year we've seen people start to recognize the importance of security, whether it is, can they trust that device that's sending data, that the provenance of that data, they really know where it came from. Can they control who can access data from the device? Can they control who is able to actually go and make changes to that device if it has actuators, and so on and so forth. So really bringing security to the forefront is definitely a need, and that's an issue that we're seeing today. And as people have started trying to secure their different IoT devices, a lot of the focus initially has been on the transport security, so encrypting the tunnel, if you will, between point A and point B. But that really is not enough. It's not the full picture. And I remember there used to be talks about, we're gonna have a VPN between point A and point B. But if your endpoint, in the older use case, if your laptop is infected with a virus, then it's you're just sending malware through a secure tunnel to the other end. So we can't just rely on transport security. And the other issue is that some of the quote unquote security that's in IoT devices today are things like default usernames and passwords. And in some cases, people are trying to use the tried and true, but not maybe quite scalable enough PKI solutions, right? So we will, as we go through the rest of the talk today, we'll distinguish between PKI in terms of asymmetric key pairs and key management versus having those built into full-on certificates that are managed and issued by a certificate authority and have long chains for validation and so forth. So we think that there is a medium there between full PKI certificates, but not throwing the crypto baby out with the bathwater, if you will. So next, some of the issues that come from those is no way to know if your device is authentic or if there's a bad actor on the other end, right? So we talked about that a little bit already. The other thing is everyone has some sort of their own IoT platform, right? And companies are trying to figure out they've got to get their devices online. They are modifying and improving their business processes, but what you're seeing is a lot of silos of different IoT platforms, and how do you manage the security across those? If you've got things flowing into one cloud over here and into some things locally, not having a central view of your security is also definitely a challenge. And when it comes down to, when you get a business process and a value chain that is relying on data that's coming from these sensors in order to make automated decisions, you can get in some real trouble if you're making bad decisions based on that bad data. So at the end of the day, it really all comes down to the trust. Do you trust that device? Do you have a way to trust the device and the people and all the ways that they're connecting? And that's what we think we have a good solution for here. So let's talk about ForgeRock Edge Security at a high level, and then we'll dive into those two new modules that Chris was talking about, the Identity Edge Controller and the Identity Message Broker. So these are the things that we're looking to accomplish here. We want to establish trust in these IoT devices and their communications and this is where I think we're onto something really interesting here. We're combining the use of strong cryptography, but we're also bridging that into standards-based identity technologies. And the way that we do that, I think, will bring that high level of security for trust while not requiring a PKI authentication at every single cloud API that a device wants to talk to. So we'll get into a little bit more about how we do that. In order to do that, we also want to have this keyword that we're hearing more about, a hardware root of trust, and that's also cryptographic method. And we're talking about the devices that we support for encryption, so that everything that we build on top of that is based on a real high level of assurance that that device is what it claims to be, starting at the factory and manufacturing. So secure configuration and attestation of devices and services, once you've got that root of trust, then you can use it as a secure channel to automatically configure things and have that device talk to, in this case, the ForgeRock backend and say, hey, I came online for the first time after the factory, and here's my information, and you can trust it because of the signatures that we've got and what's on the back end, and then we can use that to move forward into issuing standards-based credentials. And here's another place where I think the magic really comes in, is that we've got the whole existing ForgeRock platform backend, which has rich policy-based controls. It has all of the different things that you saw in the earlier slide of the ForgeRock platform. And when we're able to add in the edge attestation and security for onboarding and build those device identities in and build relationships between people and organizations and other devices, that gives us a lot of business insight, but it also gives us a way to be very granular on controlling who can talk to what and what data can go where. And then finally, building on top of that secure root again, we can actually secure the messaging in some IoT protocols like MQTT, for example, and we'll talk about that in the identity message broker. So that's an overview of the edge security, and let's jump into some of the specifics. What we do in our solution is we are able to establish a root of trust at the edge. We can provide a single platform between the edge and the enterprise. So that means, of course, if you've already got all of your users or your customers in your cloud instance of ForgeRock, and you want to add in your identities of devices, you can do that, and you can manage them together across all these different verticals. You can bring those together. Trusted identities across ecosystems. So identity can be a pretty intimate and important thing for your organization. And although you may use different IoT platforms for different industries or even within your company, the ability to have each of those different platforms talk up to the ForgeRock stack and put those things together with your user identities and what they're allowed to do, it is a very powerful thing in our opinion. Sharing security context to enable relationships, we talked a little bit about that, and enabling secure and trusted onboarding, no human intervention. So the idea there is that when that initial crypto keys are exchanged at the factory and that device comes online, when it goes out into its new home, it's able to attest itself and onboard and update its identity information. So the first piece that does a lot of what we've talked about is the ForgeRock Identity Edge Controller. That's that first module that Chris was talking about. So you can see some of these bullets here. The software for edge hardware. So what the edge controller is, it really is has two different pieces. It has the edge controller software itself, and it has a trusted agent. And this allows us to talk to the hardware security pieces of the actual chipset itself. So if you look at ARM Trust Zone, for example, in one of our initial reference implementations, we're able to talk to that trusted execution environment on the ARM chipset with our software, so that we can actually generate a private key, for example, on that chip without it ever having to leave and being managed in the highest secure way, for establishing the root of trust and for establishing a credential set on top of that that can be rotated. So that's what helps us ensure authenticity and security. And of course, when you're onboarding a device in this manner, you don't have hard-coded usernames and passwords, and we're not using full PKI certificates. So what that means is in practical terms, is that we're not relying on a certificate authority to issue a certificate. We're not using self-signed certificates, and we don't have to worry about expiration and following long trust paths in order to actually validate a certificate. The software that we have on the edge controller that runs at the edge actually does key management in concert with our back end, our new modules, and our access management. And so we can manage that, and we have all the security of those cryptographic key pairs, the asymmetric key pairs, without having to manage the certificates. So we definitely think that's an advantage. So let's see, simple onboarding of devices with zero configuration. We talked about that a little bit. The secure credentials and data signing. So the interesting thing is, once you do have this root of trust established on the device, you've got a cryptographic baseline by which you can then secure the data that's flowing from the device so that you can trust it or have non-repudiation. So everything is built on that root of trust, so that now when that data is flowing to the back end, I can use the same cryptographic baseline to either encrypt the data and have it encrypted in transport inside of a secure transport. I can have it encrypted at rest on the other end and only decrypted with the correct key materials. I can also sign that data for non-repudiation so that or data provenance, so I know that the data is intact, or it is where it came from. So it gives you a really good baseline to be able to not only secure those things, but to be able to sign and encrypt data with the same cryptographic baseline. Now you see here on the screen, we've got a Dell Edge 5000 gateway that we're showing. We've got a Renesas RCAR 3 board, a couple of examples of reference implementations that we have. So at the top, we were actually about a month ago, wasn't it, Chris? We were in Hanover, Messe in Germany, and we were a founding member of EdgeX Foundry. Yep, which Dell had started with the platform, and they put that into the Linux Foundation, and we were among the members who helped found and join that. So our Edge controller software actually runs inside of the Dell 5000 and 3000 gateways, and then also in the automotive industry, which we'll talk about more in a few minutes. We were able to run that in the RCAR board, so that if you think of an industry vertical, being able to securely onboard a car so that you know its identity as a whole car, let's say with the VIN code and other attributes, and also being able to onboard the subcomponents of the cars, with the sensors and the ECUs and those types of things, and have relationships that all of those sensors are part of the car, and here's the identity of the car, and the car is linked to this manufacturer and this owner, and so on and so forth. So a couple of examples of that, and we'll talk a little bit more about the car example and what we're doing in that industry in a few minutes. Now, we also want to be able to secure messaging over some of the really commonly used IoT protocols, which includes MQTT. So the other module that we have in there is called the Identity Message Broker, and that's about being able to, again, leverage the ForgeRock backend to securely authenticate and authorize these messages that would be either subscribing to information coming over an MQTT topic or publishing information to an MQTT topic. So securing that messaging layer, and when you build that on top of the Identity Edge controller, you're able to leverage that cryptographic baseline that I talked about again. So the Identity Message Broker, it brings that authentication and authorization, again, able to leverage the rich policy backend that we have for those data streams that your devices are transmitting. It works as a translator, so securely transforming the IoT protocols to HQTT and WebSockets, and again, leveraging the full power of the identity platform. Now I'm going to go back one slide because I thought of something I wanted to mention about the Edge controller, just to make it clear. So the Identity Edge controller and the Trusted Agent are pieces of software that ForgeRock has developed that run at the edge. And so they could run on a smart device like a car. They could run on an IoT gateway like the Dell Edge gateway, so that device itself, let's say it's the Dell Edge gateway for a minute, that device can onboard itself in a test and be trusted from the very beginning. But then that device, it also connects to lots of other different more constrained or simple IoT devices that don't talk web protocols and that are constrained. And so we can actually proxy, if you will, or do onboarding of the third-party sensors or other simple IoT devices that connect through that IoT gateway and manage those things in our backend as well. So going back to the car example, the Edge controller can live in the software that runs on the car, let's say in the head unit, the infotainment system, and onboard the car as its own entity, but then also act as a proxy to be able to onboard the other constrained devices in the car, if you will, things like the sensors, the automated advanced driver assistance things, the ECUs, and so on and so forth. So just wanted to give that example quickly. And let's go into an example of what we're doing in the automotive industry and how this can help in a couple practical examples. So ForgeRock are members of Automotive Grade Linux, which is another organization under the Linux Foundation. And in this context, we're providing personalized driver experience and the trusted vehicle identities for connected cars. So it's two different things. And again, the thing to point out here is that identity ties together lots of different pieces of business value. And when we see things like cars and other IoT devices and industries coming online, they don't function in a vacuum. You need to know about the users who are interacting with or operating those devices. You need to somehow be able to tie people to devices and people and devices to organizations, and then the big devices to the small devices. And we put this in here because we think that the car is a really good example of an IoT ecosystem that includes different people that are interacting with this now connected IoT device and all of the subcomponents that are also ultimately connected once this car gets a cellular radio and is connected to the cloud. So we're able to, in the demonstration that we've built in the software, the Edge software that we've developed for automotive grade Linux and for cars in general, to authenticate the drivers passengers to the vehicle itself. And so this is typically you take a person and authenticate them to an application or a cloud service. In this case, we're authenticating a user to the car. And then we're allowing the user to do profile management in the cloud, select their language, payment information, preferences, and have that come down in a secure way to the car. So where does the Edge controller come in? Well, the car itself needs to be an identity in that ecosystem. It needs to be known so that you know which target you're sending a user's profile to. And the car itself also wants to talk with lots of other things within the ecosystem. There is vehicle-to-vehicle communication, so a vehicle a half mile ahead on a curvy road could send your car a notification that there's a tree down or there's a car stopped ahead of you around the corner. You want those messages to be trusted. Your vehicle will eventually probably make payments for you using your payment information for smart city parking and tolls and so forth. Lots and lots of use cases where your vehicle will have its own identity and need to be trusted to talk to all different types of connected things in smart cities and other cars and so forth. So of course you want the vehicle to have its own trusted identity. So you'd have the ForgeRock Identity Edge Controller software running on the car to securely onboard the car itself and the sensors and so forth. So pretty interesting stuff. I'll end the car example here with a little architecture diagram. So on the top, you can see the traditional ForgeRock identity platform that could run in your premise or in any cloud, and it's the pieces you're familiar with. And then at the bottom is the AGL in-vehicle operating system. And so you can see it's got Bluetooth and Wi-Fi connectivity, an application framework, and several applications. So now we introduce a standards-based identity agent that we wrote for AGL, and this is how we bring the identity context of the user into the car for personalization. But then over here, you can also see the Identity Edge controller, and that's how we securely onboard the identity of the car and of the sensors and so forth. So now when a user decides that they want to create a profile for, pick your favorite car manufacturer here, you can go sign up with social login, maybe do some step-up authentication when you want to pair your vehicle with your profile and select all your personalization options, and then you use some sort of token or your eyes in the rearview mirror or your voice to authenticate yourself to this IoT ecosystem, to this car, and those credentials and that interaction could also take place via Bluetooth, and then your car via some wireless connection will then use standards-based identity protocols to authenticate you to the back end, and can also use those same standards-based tokens for the vehicle to authenticate itself to other cloud services. So if we think about this now in terms of, let's say, another industrial use case, in this case, let's say we've got connected windmills, other energy management, building management for the Edge controller. It's the same idea, but a different industry vertical. So in this case, the software could be installed at time of manufacture. The crypto exchange takes place initially. The device comes online, it calls home the ForgeRock backend, and it attests itself and says, hey, this is me. And that attestation, I'll mention here, is really the difference between using a passport to prove who you are in the person world versus showing up at a conference and saying your name and picking up a lanyard from a table. And I think it's important to point out that in the ForgeRock platform, we are able today to manage the identities of all sorts of things that they could register with a lower level of assurance, which in some cases is just fine. You hit the same API that you do, the RESTful API, to create a user. A device comes online and it can hit that API and register its attributes. And you've got a device that's online. It's maybe it doesn't require that level of trust, and it's effectively got that lanyard from the conference. But as we said in the beginning, when you've got devices that are going to be sending data, the automated decisions are going to be made on, like maybe shutting down part of a power piece if there's a power grid, if there's a notification from an earthquake sensor or what have you, pick your industry. There's plenty of automated things that are going to happen, or data that's going to be drive business decisions, where you really do need to have that higher level of trust, more like a passport. That is something that there's a rigorous process around proving the identity. So when I talk about attestation, that's really what I'm talking about, is that secure process that happens in the very beginning, that puts that cryptographic material on the secure element of a device, and is involved with the secure boot of the device and the hardware root of trust, as we spoke about. So there's all these steps along the way in the process to ensure the integrity of what's happening, so that when the thing first comes online, it says, hey, it's me, and we say, well, based on that signature, I really do believe it's you. Now let's create you a new credential key pair instead of a shared secret, which ships from the factory, and once it's compromised, you really have not very many options. Whereas when you have a hardware root of trust, when those key pairs are issued on top of that, they can be rotated, which is a great thing. You can't rotate shared secrets as easily. So, and then on top of that, again, you turn that into standards-based identity tokens that can then make it easy for your device to authenticate to all different types of cloud services, but built on a chain of trust that goes back to something that's a cryptographically sound baseline. So in summary, if it's connected, it needs to be secured, regardless of if it's a forklift, if it is a wearable, cargo containers, turbines, cars, parking meters, all of these things. There's different levels of trust that are needed, and what we're really doing here with Edge Security at ForgeRock is spanning that full spectrum, so that if you need a simple onboarding and you don't need a lot of security, great. But in those cases, increasingly where you do, we have the ability to offer you that with this bridge, if you will, between the world of PKI and the world of standard authentication tokens, and being able to make that happen. So I think I'll turn it back over to Chris, and we'll wind up and we'll get ready to take some of your questions.
That's great. Well, Ashley, that's awesome. Thank you. Let's talk for a second before we get to these questions. And if you do have some, please go ahead and type them in. We got a couple of concepts here that we're going to talk about from some comments that people made. But before we get into that, let's talk a little bit about our early access program for ForgeRock Edge Security. We have the slide up here, and all the things that you've been talking about is kind of a mixture of things that people can do today with the platform,
right?
Primarily using our universal authorization feature for a lot of the sort of classic IoT use cases, and then some of the more cutting edge stuff that we have around the edge stuff. And I think the edge stuff is really something that we're trying to get into people's hands, or to get feedback from people as soon as we can. So that's where this early access program comes into play. So can you talk about that a little bit?
One of the things, so I work in the CTO's office, and we focus on innovation in these areas, and we don't like to try to just come up with something in a vacuum and then wait until the end to say, oh, is this something that people want or not? So we're very much about getting out and talking with customers, talking with prospects, bouncing ideas off. And that's really what led us to where we are today with Edge Security and with the Edge Controller and the Message Broker. And to carry that forward, as we're taking this through our process of product management and engineering, we really want to continue that thread of having folks who would be essentially early adopters to work with us and to sign up and to take a look at what we're doing and to give us feedback on the use cases, so that as we take it from where it is today to where we're going with it, that it includes feedback and it includes the features that are best suited to the real world use cases that that our customers, our customers today and our customers of tomorrow will be the most useful for them.
That's awesome. So yeah, so please, if any of this Edge stuff in particular is interesting to you, go ahead and hit that link there, that bit.ly link, and sign up for the early access program, and you'll be the first to get notifications on new developments as we go through this process. I see a couple of questions here around this idea of hardware root of trust. I think maybe there's some confusion about how that trust chain works. So can you maybe kind of go into that a little bit more?
Sure. So the hardware root of trust is really something that is often established at the time of manufacturing. It is related also to secure supply chain, and a lot of times it deals with a key, some sort of key that may be put on a chip or on a device by a manufacturer to say this is actually this is our device. It could be PKI certificate. There's even some new technologies. I can't remember the acronym, but it's called PUF, where you can actually, it's provable, unchangeable, and something else I don't remember, but it's actually a way to physically on each chip kind of identify it uniquely in a way that can't be changed without destroying the chip. But the hardware root of trust really is saying that it's going all the way back to, if I were to compare it to something in the human world, it's the difference between I'm going to just sign up for Facebook and maybe I am who I say, maybe I'm not, versus I need to go and do some sort of in-person identity proofing. I need to bring my birth certificate. I need to bring a driver's license. I need to, my passport, those types of things to really prove that it's me. It's that same idea, but at a hardware level, so that, and then of course, since it's not a person, the way that that's bridged usually is with cryptography, so that the keys that are generated and the way that they're put on there, either by a trusted human in a secure area of the manufacturing, or with the emerging PUF technologies that ensure that is burned in. It's really hard to hack or to circumvent without actually destroying hardware, and it's tamper-proof and those types of things, so that's the foundation on top of which we build the rest of the things. That's how we use that to then connect it out to more standards-based protocols. But the hardware root of trust is not something that can just be changed. So it's the thing that you always go back to if you need to rotate a key or if you need to do something different.
Interesting. Okay, so I see a couple of things here around how it talks to the platform. I think there's some questions there around, I guess ForgeRock Access Management is going to be involved in, even though these things are on the edge. So can you talk about that a little bit?
Yeah, that's a good question, and I think it's a thing I forgot to cover a little bit. Is that part of Edge Security and these two new Edge modules that we talked about? It also includes some updates to our access management platform in the form of two new authentication modules. So if you're familiar with the ForgeRock authentication architecture, we have authentication modules and authentication chains that we continue to improve to provide more and more options of how you can go through a process of authenticating typically a person, where they could start off with an ID and password, and then if they want to go do something more sensitive, they might have to bump up to a second factor. And even with contextual authorization, basically you're flowing through these different modules based on the rules to determine if you're authenticated or not, and even if you are authenticated, maybe not at a certain level of assurance. So as part of Edge Security, we've developed two new authentication modules, if you will. So when that device first attests itself, based on the hardware root of trust, it hits the first authentication module, and that's verifying those signatures so that we can verify on the back end, complete that attestation to know that it actually is the piece of hardware that's claiming to be. And then the second one is actually being able to authenticate that device from the Edge controller to our back end, so that we can then have an authenticated session, if you will, on the back end, and be able to issue that device the type of standards tokens that we talked about, whether that's OAuth 2 token or OpenID Connect on top of that, and so forth. So yes, two new authentication modules in our access management that provide the back end, if you will, or the other side of the additional functionality that our new Edge software provides. Great.
Okay, so I see another one here. So I know the word proxy can mean a lot of different things, but people are wondering, is this sort of a local proxy for ForgeRock Access Management? For accessing proxies IoT devices in front of ForgeRock access management.
Yeah, and it's interesting whether we say proxy or third party. What that's really about is that, if we divide, sometimes we say constrained or unconstrained, or we'll say a smart device or a simple device. But the bottom line is there's connected devices out there that have enough CPU and power and connectivity to actually talk web protocols. They can talk HTTP. They can talk on the internet, and they have the chipset that can support this trusted root, like the ARM Trust Zone. And then you've got other things like a O2 sensor in a car, or other sensors or ECUs that they're just not going to hold. They're not going to have enough power or CPU or physical power or connectivity or radios or whatever to be able to support that. And so what the Identity Edge Controller does is, in addition to be able to attest and onboard itself, it can then do that. It can perform that function for devices downstream of it, if you will, that are constrained, but that are connected, let's say, to a gateway or to the infotainment system of the vehicle, so that those sensors and those other things, they already are connected to something more smart in that ecosystem, whether it's a gateway of some sort. And that gateway usually takes inbound, more constrained IoT protocols and brings in data from those sensors and translates it out into something that goes out to the cloud. So we also want to, in many cases, understand, manage the identities and credentials for those constrained or simple devices. And so the Edge controller, in addition to being able to attest and onboard itself, can effectively be a proxy for onboarding, bringing the identities in for and managing credentials on behalf of these simpler devices, so that they can also be accounted for in the identity ecosystem.
Cool. All right, we're going to wrap up here in just a couple minutes. So if you have any last questions, please do throw them in the chat window there. Actually, one thing I want to talk about before we go is context. Mm-hmm. That's something that the platform is well known for, its ability to use contextual information to make authorization decisions.
Yeah.
So it seems like there are a lot of use cases where being able to use that sort of information to make these decisions for edge devices could be really useful.
Yeah, and I think that goes back to some of the problems that we talked about on the earlier slides, problems with IoT security, where you have some of your devices going into this quote unquote platform and some going into the other, and there's really no big view of what level of security those devices have, what their identities are, or how they fit into the bigger ecosystem. So, it's true, our back end has all that ability to do those contextual decisions about identities and access, and as soon as you add in those devices of constrained or smart devices, what have you, and start mixing them in and building relationships between the organizations that own them and the people that can see them and the people that can manage them, suddenly all of our contextual capabilities light up, not just in the context of a user who may be trying to come from two different places across the world at the same time. All of that contextual capability can be applied now to the more complex set of users and devices and organizations and locations and all those types of things. So the ability to do that with identity relationship management and building sort of a web or a graph of the relationships between those things is really going to be a powerful thing for our customers. And the context that you mentioned is interesting, because it is in the context of security, but it's also in the context of giving our customers additional insight into what's happening with their devices and either how they're performing or how they're connected. So security, but also business insight is something that will end up being provided from this, because it's going to be one of the only, if not the only place where you can see all of your identities together and get more information about that.
Excellent. All right, this is going to be our last question here. So there's a question here around cyber impersonation and the initial process of self-registration. So I think that goes back to the secure onboarding.
Yeah, for the device.
For the device, I believe, yeah, for the device or person as the device registers themselves in the onboarding process. So maybe talk about that a little bit more. Like, how do we ensure the first time a device is turned on that it's authorized to be there? Yeah,
and that really goes right back to the hardware root of trust and the attestation and sort of the secure factory process, or the equivalent of onboarding when you've purchased a bunch of devices in your organization and you're getting ready to roll them out. It's really about if I go to try to take a similar device and buy it off of Amazon or buy it from whoever the supplier is, and I want to bring it in to your organization to try to spoof or to impersonate that device, talking about devices at this point, I won't have the cryptographic secrets that were used between the factory process and the ForgeRock backend to be able to affect that signature. It's sort of like smart card security. If I have a smart card from when I worked in the federal government, it has key pairs on it and it had a secure process. If I was just using an ID and password, it'd be easier for you to find a way to steal it or impersonate me. It would be very much more difficult for you to try to impersonate me for something that required a smart card authentication, because I have to have the token, I have to know the PIN in this case, and I could even use biometrics. So it's that same type of thing that the attestation and the root of trust does that makes it so hard to actually be able to impersonate.
Okay, I think we'll try to squeeze one last question in here. This is around virtualization on Edge to provide security by separation and reduce the attack surface. So do we do anything along those lines in this architecture?
Yeah, I mean, part of the trusted execution environment is it's not virtualization in the way that you'd think of a VM, you know, in your typical cloud, but it is a separate process that is separate and apart and secured from the rest of the operating system and the rest of the CPU architecture. So in that case, our trusted agent and the ability that we have through our integration to talk on that secure channel and integrate with that secure channel is, I suppose, is a form of virtualization. It may not be what the user the attendee is asking, but as far as the software, our identity and edge controller software and our trusted agent, they're not running in little VMs on the edge, but in terms of being able to talk to the special and separated trusted execution environment, they are able to do that.
Right, there's hardware isolation there at the chip level.
That's right.
Right.
That's right.
Excellent. All right. Well, I want to thank everybody for joining us today. This has been a really informative call for me this morning. Thanks, Ashley.
Thank you. It's great to be here.
And if you would like more information, again, please hit that URL there on the screen and sign up for our Edge Early Access program, and you'll be the first to hear new information as it becomes available. And make sure you check back for the next ForgeRock webinar. You can check our events page on ForgeRock.com. And we hope to see you again on another ForgeRock webinar. Have a great day. Thanks.